Hello, everybody. Today's topic is signal strength measurement in wireless communication systems like 5G. Some of the things that you'll take home after watching this video are why do we need decibels in signal strength measurements? What are some of the 5G system measurements like SINR and RSRP? These are the 5G signal strength measurement units. So let's start with learning about the motivation to learn this topic or the problem statement. So imagine you have a wireless device or a mobile phone, and you bring it out to make a call to a friend or to surf the internet. The very first thing that the mobile phone needs to do is it needs to connect to something called as a base station. So a base station is nothing but a cell tower that relays the information from a mobile phone to another mobile phone or from a mobile phone to an internet server. So that's a base station. And as you can see in this picture, a mobile phone can actually see multiple base stations at all points, and it needs to do some cell measurements of SINR and RSRP to decide which base station it needs to connect to. In this case, looking at these distances and the values, we can see that SINR1 is less than SINR2, RSRP2 is more than RSRP1, hence the better base station is base station 2. So the cell measurements resulted in this answer that which base station the device needs to connect to. It's a very basic understanding of the problem and how SINR and RSRP helps in resolving that. So some of the questions which might arise in your minds after listening to these parts is, what are these terms, SINR and RSRP? Why are they measured in dB? What is dB? What is dBm? Why do we need it? And why do we need multiple parameters, RSRP, SINR? Why isn't one parameter enough to do the cell selection that I spoke about? So we'll try to answer all these questions in this video. So let's start with part one. Why do we need decibels in signal strength measurements? So I'll start with explaining decibels. So decibels or dB are a unit which are used to measure the relative strength of something. So this term is very important, relative strength, because it's actually always comparing two values. So decibels are a way to measure relative strength of something compared to a reference value. It's a way to express the difference between two quantities on a logarithmic scale. So logarithmic scales are used whenever we're trying to work with larger ranges of values. They come in very handy in working with large ranges of numbers. And I'll explain you a bit more about logarithmic scale and why it helps in some time. One thing to remember or to note is each increase of 3 dB represents roughly doubling the intensity of the signal. So this is a very important fundamental truth about decibels, which could be very useful as an intuitive sense of dB. Similarly, negative 3 dB will be half the power. Now let's go to dBm. So dBm is a unit used to measure power levels. It stands for decibels reference to 1 milliwatts. So as we spoke about in decibels, it's always measured relative to something, relative to a reference level. And when the reference level is milliwatts, or to be specific, 1 milliwatt, the unit is called dBm, decibel milliwatts. That's how it is. So when you're talking about decibels, there are two relative values, and when it's dBm, it's the measured power level with reference to 1 milliwatt. So it tells us about the power of a signal compared to a reference level. And to understand dBm, let's consider the reference point of 1 milliwatts. So if a signal has a power of 0 dBm, it means it is at the same level as 1 milliwatt. That makes sense? So 0 dBm is 1 milliwatt. If the power is higher, say plus 10 dBm, it indicates that the signal is stronger or more powerful than 1 milliwatt. Similarly, a negative 10 dBm means the signal is weaker than 1 milliwatt. So 0 dBm is 1 milliwatt. This is the reference value. I hope that gives you some idea about dB and dBms. Now, why do we need dBms? What is logarithmic scale? That's what I'm going to try to cover here. So, why do we need decibels? If you see on the left here, these are nothing but the RSRP measurements that are actually present in 5G systems. All of these values are what you will see on if you open up your phone and if you're able to see the RSRP measurements that it does. And the top ones are good good signal strength. These ones are okay, and these ones are poor conditions. But all of these are real RSRP values. So on the right, you see them actually represented in milliwatts. So since these signal strengths are nothing but power, they are measured in watts and milliwatts. As you know, watts is the SI unit for power. So just looking at this from the top level, you can easily understand why you will need dBm. They are large values, and it's so difficult to work with 0.000000001 milliwatts. Hence, require dBm. On this plot that I generated on MATLAB also shows the same thing. With increasing distance, your signal strength in RSRP will reduce, and you can actually make sense of it on the left plot, figure 1. But here in figure 2, this is very difficult to make sense of. Hence, we use dBm or dB scale or logarithmic scale for signal strength measurements in systems like 5G. Let's go to the second part of this video that's specifically talking about SINR and RSRP. So what is SINR? Another note here, it's measured in dB. Okay, that gives you some intuition. So SINR stands for signal to interference plus noise ratio. It's a quality measurement in wireless networks that measures the strength of signal compared to unwanted interference and noise. So if you see here, unwanted interference, unwanted noise, signal strength, so many different things. So now let's imagine that this is another MATLAB signal that I've generated to explain this concept. So a base station that we spoke about will be sending sinusoidal signals. Everything in telecommunications is sinusoidal signal. So it sends the sinusoidal signals with this particular amplitude here. It goes from 19 to 21 dBm. Now, the noise level in this case is 2 dB. Interference is 5 dB. What is interference? What is noise? So interference is nothing but signals that could be falling in the same frequency range. And this could be generated by machines, or it could be generated naturally. And this could interfere with the signals that our base station is trying to send to the mobile phone. Another thing is noise levels. These noise levels are always present. They can be considered as random, and the intensity is usually smaller compared to the sinusoidal signal or the signal that the base station is actually trying to transmit. So here on the bottom, we can see an SINR plot, which shows the amplitude in dB compared to, and we can compare this with the sent signal. So if you see the signal strength, the amplitude has gone from 21 to 17. And this is because it was affected by a noise of 2 dB and an interference of 5 dB. Now, why? So now it's very easy to understand because we're comparing multiple terms, we're comparing multiple quantities, we use dB, and we have SINR. It's nothing but your signal divided by interference plus noise. That is SINR for you. Now let's go into RSRP. And this is very critical. So RSRP measured in dBm. So this is something interesting. So RSRP stands for reference signal received power. So this represents the power level of a reference signal which is transmitted by our base station. So what do you mean by reference signal? So a reference signal is nothing but a signal that the mobile phone already knows about. So the mobile phone knows that the base station is going to transmit this particular reference signal at this frequency at this time. So all the signals sent by base stations are specific to frequencies and times. So the mobile phone already knows that at this point in time, at this point in frequency, the base station is going to transmit this particular reference signal. And on top of that, it also knows the strength that the base station is using, or the power that the base station is using to send this reference signals. So it already knows the strength at the base station, and it measures the RSRP, or the reference signals, at the mobile phone. So now it has an absolute value. It has an absolute value in milliwatts. It has this absolute value in milliwatts, and it converts this into dBm. And since this value is not relative to something else, but it's an absolute measurement, it's done in dBm. And this RSRP is used for synchronization purposes and for communication purposes between the base station and wireless devices like mobile phones. It can also tell you how much loss is there between the base station and the mobile phone. So how strong the signal is at the receiving end. The greater the RSRP value, the stronger the cellular signal. Very intuitive. This table or a chart also indicates some of the common values that we see in LTE and 5G systems for RSRP measurements versus what we indicate as good, poor, fair signal strength. The next part of this video is MCQ questions. I'm not going to be giving you any answers, but these are a bunch of MCQ questions that we prepared, which you'll be able to answer based on the understandings from this video. I've also included some brief questions for you and some further reading topics. So these brief questions will cover some things about why do we need RSRP and SINR both? Can you actually think about and write down these answers? What are the advantages of one over the other? What's the difference between dB and dBm? All of this has been covered in some extent, and I want you to think about it more and answer these. Another further readings that I will recommend is RSSI and RSRQ. These are also some more measurements that mobile phones do in 5G wireless communication systems all the time. I hope this video has been useful for you. Happy learnings. Thank you.